All right, today we're going to be looking at polynomial inequalities. The process of polynomial inequalities is going to look familiar because it is familiar. Last unit in Module 2, we looked at inequalities that dealt with quadratics. So let's start with a problem that we could have solved and we should still know how to solve from last unit. So let's solve x squared minus 2x greater than 3. So how do we go about doing this? Step 1, we know we need to get our right hand side equal to 0. So let's get right side equal to 0. So how do we go about doing that? We can do that by subtracting 3 from both sides. So we get x squared minus 2x minus 3 is greater than 0. All right, step 2. Do you remember what we do next? Yes, we need to factor. So we can factor our quadratic into x minus 3, x plus 1. Step 3, we need to identify our zeros or our x-intercepts. So the zeros that we have for this particular one, that's going to give us x equal to 3 and x equal to -1, and we got that by setting each factor equal to 0. All right, step 4. This is where we put our zeros or our x-intercepts. We're going to put them on our coordinate plane here. So we're going to be just looking at our x-axis to begin with. So we have -1. We got 0, 1, 2, 3. And because our inequality, we have this inequality here is greater than 0, we're going to have to put open circles at our zeros. And why don't we go ahead and just separate our domain here into 3 sections, A, B, and C, because our solutions are going to reside in one of these, one or more of these different regions. All right, so what did we do next? Next, there was a couple of things that you can do here. Last unit, we looked at testing points to see which regions satisfy the inequality. And another way we looked at it was by graphing. So why don't we go about it that way for this example? So why don't we do a sketch, our quadratic. If I could spell. So we want to sketch it. So we need to look to see what our A value is. Our A value is 1, so this tells me my parabola is going to be opening up. So we know we're looking at a quadratic that has to be opening up. And when we look at it, once it's graphed, again, we're looking at what values of x is the output going to be greater than 0. Well, we can see that in section A here, or region A, and region C, we have y values that are above the x-axis. So that means that it's greater than 0. So that means all the x values that fall in this section and all the x values that fall in this section are going to satisfy this inequality. So our last step is to state our solutions. So our solutions are going to exist in section A here. So that would be from -infinity to -1. And in section C, which is from 3 to infinity. So hopefully you will find this as a good reminder from Unit 1. All right. Let's move on to our next example. And let's take a look at an example that has a higher degree than 2. So in this next example, why don't we solve the following? And I'll give you this one in factored form. Suppose I have -4 times x minus 1 cubed times x squared times x plus 1, and suppose that is less than or equal to 0. So here's our inequality. So step 1, going back looking at our example, we said step 1, we need to get the right hand side equal to 0, and we already have that. Step 2 is to factor, and we already have that. So we're already at step number 3. So what we need to find here are the zeros. So let's do that. So looking at each of our factors, so why don't we set each one? So here we have -4, but -4, that can never be 0, so we don't need to look at this one. But we do need to look at this factor. So here we have x minus 1. We need to find the 0 of that. We have x squared. Find the 0 of that. Or just x. We'll come back and talk about that. Let's just look at x equals 0. And then we have x plus 1 equal to 0. So our zeros are going to be x equal to 1, x equal to 0, and x equal to -1. Now, since we're dealing with polynomials higher than degree 2, we need to look at the multiplicities for each one of these. So the multiplicity here, we have a multiplicity of 3. So we know this one is going to have more of that cubic, that little squiggle that we see when we graph it. The multiplicity at 0 is a 2, so we know at this 0 we're going to have some sort of a bounce or a touch. And then the multiplicity at -1 is just 1, so this one's going to have a linear behavior around that 0. So we have a cubic behavior, we have a quadratic behavior, and we have a linear behavior. Alright, so we are ready to put these zeros on our number line. So we have a 0 at 0. So we'll put 1 here. I'm going to skip by 2's. And let's put 1 here at 1. And we have another one here at -1. Alright. Now for this one, because we're looking at less than or equal to, I'm going to have a closed circle at each of our zeros. And let's go ahead and separate out the different sections here. We have a section A, B, C, and D. All right, now in order for me to get a nice graph of this polynomial, we also need to look at the leading coefficient, and we also need to look at the total degree. So basically, we need to find the end behavior. So what's the end behavior of this polynomial? All right, so we start with our leading coefficient on the right-hand side, and we see that that is a -4. So that tells us that our right-hand side is going to be trending down. And then we need to look at the degree of our polynomial for our left-hand side. And so again, if you remember, our degree would be the sum of all of our multiplicities added together. So we have 3 plus 2 plus 1, so that's going to give us a degree 6. So that's even, so that means that my left-hand side has to match my right-hand side. So let's go and get a nice sketch of our polynomial. So let's start with section A. Section A, we know that we have to be trending down. Now at -1, we do have a multiplicity of 1, so we know that this is just going to go through linearly, and we know that we're going to have a sketch going down. In section B, going from -1 to 0, at 0 we have a quadratic, so we know that since this is coming up, it's going to have to bounce at that 0. And then when we get to 0 at 1, we have a multiplicity of 3, so it's going to have to come in sort of cubic, and then it's going to go through, and then it's going to trend down to match up our end behavior. So we end up with a polynomial that has this following shape. All right, now looking at which sections are going to satisfy, we're looking for values of our graph, or our y values, that are going to be below the x-axis where it's less than or equal to 0. So equal to 0, I'm equal to 0 at my zeros, and I'm less than 0 here, and I'm less than 0 here. So basically all of section A And why don't we go back in and let's continue our little divisions here so we can see. So all of section A will satisfy, all of section D will satisfy, and then we don't want to forget our 0 at 0. So in between sections B and C, we have to pick up that one particular value. So let's write out our solutions here. Our solutions are going to be from negative infinity to negative 1. We need to include the negative 1. Let's pick up 0. So there's a lot of different ways to write this, but if you want to just include the one value 0, you may do it like so, or you can use curly braces here. And then we're going to pick up on the right hand side section D. That's going to start at 1 and go to infinity. So this would be the solution to this example.